Hello friends, today I'm going to solve LeetCode problem number 2279, maximum bags with full capacity of rocks. In this problem we are given two arrays, capacity and rocks array. The capacity array represents that the ith value in the capacity array is the total number of rocks we can put in that bag, and the rocks array is the total number of rocks currently in the ith bag. And what we are given is also an integer additional rocks, which is the additional number of rocks that we could put in any of the bags. And the final result that we need to return is the maximum number of bags that can be filled till full capacity after placing the additional rocks. So what are we actually asked is, let me just show you here what does the question actually mean. So this is the capacity, which means that there are 4 bags, each is starting from 0 index, 1, 2 and 3. So we have 4 bags, bag 1, bag 2, bag 3 and bag 4. Each of these has capacity 2, so we can fit 2 rocks here, 3 rocks, 4 rocks and 5 rocks in these bags. But currently we only have these many rocks in each of the bag, which is that this bag only has 1 rock, this bag has 2 rocks, this has 4 rocks and this has also 4 rocks. So far we know that this bag is only filled till full capacity. Right now what we need to do is we are given additional rocks as well, and we need to determine the bag to which we could fill to the full capacity. So how many remaining rocks can we add to this bag? Basically 1, right? So we can add 1 additional rock to this bag. What about this bag? Of course it's also 1. And what about this bag? Well, we cannot add any rock to this bag, it's 0. What about this? So it's also 1. So since we have the list of additional rocks that we could fit in each of the bag, now we also have the number of rocks that we can fill any bag to full capacity. Now to get the maximum number of bags filled till full capacity, we need to fill the bags which only require less number of rocks to get filled. Suppose, for example, here we have bags which can accommodate at more 0 rocks, 2 rocks, 1 rock and 3 rock additional. So these are the additional number of rocks that each of the bag can accommodate, and we are only given 2. Okay, suppose we are given 3 additional rocks. So how should we fill our bag so that we will get the maximum number? Well, 0 is already, this bag is already filled because we cannot add any rocks in this bag. What about this bag? Okay, let me just modify my my example a little bit so that it's suitable for this example here. Yeah, so let me add one more here. So we have additional 2 rocks and we have 5 bags each of so we can fill these additionally with 2 rocks, 1 rock, 1 rock and 3 rock. Now if we fill this bag, then how many will be remaining? Basically if we fill this bag, then we will fill all of the rocks, right? So the remaining rock will be equals to 0, and then we will only fill one of the bags. So total will be this bag plus this bag, so only 2 bags will be filled to the full capacity, right? But what if we do not fill, instead of choosing this one, we fill this bag which requires less number of rocks to get filled, right? If we fill this bag, then the remaining number of rocks will be equals to 1. And then next, if we fill this one, then the remaining rock is equals to 0. So how many bags have we filled to capacity, which that it is 1, 2 and 3. So we have filled 3 bags, right? So what does this mean is that we need to fill those bags which require less number of rocks to fill to the highest capacity, so that we get the maximum number of bags that are filled to the highest capacity. So for that, what are we going to do is we are going to sort these bags, and once we sort, we can just move in a linear manner. So starting from 0, since it's already filled, it doesn't change anything. So we fill this one bag, and then the remaining number will be equals to 1, remaining rock will be equals to 1, and then we fill this bag, and then next, when we move to the next one, the number of rock is equals to 0, right? So we just break out of the loop. And yeah, so that will be the way we will be performing our action. So what we'll do is we'll first of all find the remaining capacity of each of the bag. The remaining capacity is capacity minus the rock in each of the bag. And once we found the remaining capacity, we are going to sort this out. So once we sort this, and then we are going to fill this sorted array with the additional rocks until and unless the number of rock is equals to 0, or we have reached the point where the remaining capacity is greater than the number of additional rocks remaining. So now let's dive into our code. So let n equals to, so what do we need is we need the remaining capacity, right? So I'm just going to change the capacity array. I'm just going to modify the capacity array. Now we have the array with remaining capacity. We will sort this out in an ascending order. Now once it's sorted, what do we do is now we start from the first index in the remaining capacity array, and then we fill it until we have reached the value equals to 0, or until we cannot fill any additional bags to the full capacity. So starting from index I equals to 0, I is less than n, I plus plus, if additional rocks equals to 0, or capacity of the bag I is greater than the number of rocks that we have remaining. Then we just break out of the loop. Else what are we going to do is we reduce the number of capacity. We also need a result variable to store our result. Capacity will additional rocks, the number of additional rocks will decrease as we keep filling the capacity, the bags with the remaining capacity. So once we fill the bags with the remaining capacity, we are also we got one more bag with which is filled to the capacity, right? So we increment our result, and then finally return our result. Cool, let's submit it now. So the time complexity and the space complexity would be since we are not using any additional space, because we are reusing the same space that we were already given, that is the capacity array. So the space complexity is O of n, that's constant space complexity, and the time complexity is, since we are sorting our array, so it's n log of n time complexity for sorting, and this is n time complexity, and this is also n. So basically it's 2 times n plus n log of n, but the resulting time complexity, that would be n of log n. So yeah.